Okay, let's do range. Range in interval notation is going to be very similar to domain in interval notation. Okay, for domain, we said start at the left. And why are we starting at the left? Because the domain, these are our input values. Sorry, Michael, if I end up drawing on you. The domain is a set of input values, and input values are the x values that we use. Okay, so that's why we start at the left, because the x axis goes left to right. So we start at the leftmost point of the graph and trace. Wherever we pick up our pencil, that's where we have to exclude the value of x, and then we continue moving to the right whenever we see that graph pick up again. Range is similar, but range is a set of output values. Okay. And because it's a set of output values, we're not looking left and right, we're looking up and down. So we're looking at our y values. So instead of starting all the way on the left, we're starting at the lowest point and tracing. Now, again, if we pick our pointer off the page or off the screen, the range breaks. We need to exclude that. Then continue again if the graph continues somewhere else, even if it's on a totally different piece of the graph. So we're going to start with some pretty easy ones, okay? And that, in fact, they're the same graphs we had from before. I'm not going to get the curtain out to cover this stuff up, all right? I'm just going to use that definition or that step-by-step process in the last page. So what's the lowest point of this graph? Not the lowest point that we can see, but where would the lowest point of this graph is? Where would it be? The lowest point of this graph is going to be at negative infinity because this graph keeps going down, right? Now, I want to make this point clear. When we were doing domain, this was also negative infinity, but it was negative infinity because this graph was going all the way to the left. That's where x values are negative infinity. Y values are also negative infinity here for the range because it's going down as well. So then as we trace this graph, as we do with range and domain, are there any breaks? Do I have to pick the pencil up off the page as I'm tracing? No. So since I didn't have any breaks in that domain, it never stopped the range, then the range here would be from negative infinity, the lowest point, to positive infinity, the highest point. Because again, this graph's going to keep going and going and going and going. I just can't draw the whole thing. Let's go here. What's the lowest point of this graph? It's not this point. This is not the lowest point. The lowest point, what's the bottoming out point? It's right here. Okay. And again, we're looking for y values now, not x values. So and this is a difficult thing for people to understand. They see this point, it's 5. It's sitting on top of 5 right here. And people want to write 5. But when we're doing range, we're using y values. So what is the y value of this lowest point? The y value of this point has coordinates 5, 0. So the lowest point has a y coordinate of 0. And then we trace up. And yes, we are tracing to the left. And in America, in the English language, we typically do things left to right. That's not how things around the world go, but that's how we're used to doing them, right? From left, we read from left to right, right? We scan a room from left to right. All of these things, right? Domain range is a little bit weird like that. We just start low and move up, even if it means we're moving to the left. So we're moving up, we're moving up, we're moving up. There's no breaks, there's no breaks, there's no breaks. This graph is going to keep going up. It's going to go up and to the left, but I don't care that it's moving to the left. I only care that it's moving up and it never breaks. So the highest point is infinity. We always use parentheses around infinity, okay? And then because this point exists where the output is 0, we use a bracket and not a parenthesis. Okay, we talked about how if we put the number 5 in here, we're taking the square root of 0, and the square root of 0 is 0. This is an actual output on the graph. So I am using a bracket because I do see this as an output to the function. Last but not least, let's look here. What's the lowest point of this graph, right? We said this is going to go forever and ever down. So the lowest point here is negative infinity. All right, so we start at the lowest point and we trace and we look for any breakages, and I don't see any. I don't have to pick my pencil off the page if I want to keep tracing. Okay, now it starts to look like it's flattening out, and you'll learn more about logarithms in a later unit, but this graph is growing. It's just growing incredibly slow. So it is going to reach a high point of positive infinity. It's going to take way too long for us to trace it to get there. So there were no breaks. I started at the lowest point, I traced, there were no breaks in the graph, and I keep going up. So this goes to positive infinity. Okay. Lowest point, highest point. Always parentheses around infinity. Okay. Brackets around numbers we want to include. And if we ever pick our pencil up off the paper when we're tracing, we have to write that number down.